Have you ever wondered how computers perform calculations? This intriguing process is governed by computer arithmetic, a cornerstone of computer architecture. It's how machines handle everything from basic sums to complex equations. At the heart of it all is the binary system, a language of ones and zeros. This simple two-symbol system perfectly matches the electronic nature of digital circuits. So in the digital world, something as basic as the number 5 transforms into its binary equivalent, 101. Let's dive into fixed-point arithmetic. In this format, numbers are represented with a fixed number of digits after the decimal point. It's like having a pocket change jar, but you're only allowed a certain number of coins. This method is particularly useful in applications where precision is key, such as financial calculations. Picture this. The number 3.75 is represented as 375 in a fixed-point system with 2 decimal places. So, the fixed-point representation of 3.75 with 2 decimal places is 375 in binary. Now what about dealing with very large or very small numbers? That's where floating-point arithmetic comes in handy. It's like scientific notation for computers, comprising a sign bit, an exponent, and a mantissa. This representation allows us to handle a broad spectrum of numbers. For instance, consider the number 0.00123. In floating point, we express it as 1.23 times 10 to the power of -3. Thus, the number 0.00123 in floating point representation is 1.23 x 10 circumflex minus 3. How does a computer perform basic arithmetic operations? Well, just like we do, but in binary. The operations include addition, subtraction, multiplication, and division. Let's take a look at binary addition, for instance. Suppose we want to add 13 and 10, represented in binary as 1101 and 1010 respectively. We start from the rightmost bit, just like in decimal addition. If we carry it out, we find that 1101 plus 1010 equals 10111, which is 23 in decimal. So 1101 plus 1010 equals 10111 in binary. Ever heard of the arithmetic logic unit, or ALU? This key component sits within the CPU, the computer's central processing unit. The ALU's main task? Executing both arithmetic and logic operations. It's the maestro, conducting the symphony of processing numerical data in computer architecture. From simple sums to complex equations, the ALU is the heart and soul of the operation. This little unit is the unsung hero of your computer. In a CPU, the ALU is the brain behind operations like adding 2 numbers or comparing values. As you can see, computer arithmetic is not as complex as it may seem. It's a cornerstone of computer science, underpinning everything from basic operations to complex calculations. We've journeyed through binary representation, fixed and floating point arithmetic, arithmetic operations, and the pivotal role of the arithmetic logic unit. No matter the evolution of technology, these concepts remain at the heart of computational systems. As technology advances, a strong grasp of computer arithmetic becomes increasingly important. So keep exploring, keep learning,